How often do you start thinking about the construction project and realize that you need more than just the material? That your project will gain efficiencies from taking on a reliable partner. A partner who will help you with end-to-end implementation of your project, right from planning and design to installation, all to ensure sustainability throughout. How do you come to these conclusions and what challenges do you face? Hi everyone and welcome to ViaCon's latest webinar, Achieving Sustainable Construction with Geosynthetic Reinforcement Solutions. My name is Frida and I lead the marketing and communication team at ViaCon. Today's webinar will provide understanding and knowledge about the applications of geosynthetic reinforcement materials in construction and the important parameters in selecting a good and sustainable solution. With me in the studio, I have Pyri Pispanen, the Managing Director of ViaCon Finland, and Branimir Bratov, Product and Solutions Director for ViaCon's Geotechnical Solutions business unit. Let's start with you, Pyri. Could you tell us a bit about the different kinds of challenges in construction using geotechnical solutions?
Of course, Frida. I would say the main challenge in construction is when the focus is primarily on materials to use. There are many factors that need to be considered for construction to be sustainable. Building on a soft soil with insufficient bearing capacity can lead to various problems, including differential and excessive settlements, structural damages, and even collapse. When approached from a solution outlook, all these challenges can easily be solved as well as streamlined.
Okay, this makes sense. I think not just only for me, I believe our audience would also like to know more from you and Branimir about the main challenges in construction where geogrids and woven geotextiles can be used to achieve a sustainable construction process. So Branimir, how do geosynthetic reinforcement materials support and facilitate the construction process? And how can designer, construction companies and authorities best benefit from their use?
Well, Frida, reinforcement geosynthetic materials have been used for more than 40 years now, and they have mainly been implemented as products for soil stabilization and reinforcement in roads, railway, and mining construction. The main materials that have been used for reinforcement are woven geotextiles and geogrids. Their application also includes retaining walls, load transport platforms, veneer slope stability, and number of other applications. I would say that the success of a project heavily depends on having the correct understanding of both the material and all applicable parameters.
I totally agree with you, Branimir. And I think projects start well before delivery of the material. And one needs to evaluate which solution is the most suitable for each case. Very often in many projects, we have noticed that problems can be avoided when we've had a systematic approach, such as evaluating the application, the desired durability, and the environmental aggressiveness, and many other conditions. And this all needs to be considered holistically. Of course, understanding the matter usually requires both expertise and experience. At ViaCon, we have been providing both consultation and support in all phases of the project, including designing, installation, and assessment of potential risks, not only during construction, but also in operation.
So, from what I understand, it appears as though taking a solution approach is the key. But coming back to the challenges we have in construction and geosynthetics applications, how do geogrids and woven geotextiles work and where do you see the biggest potential for them in construction industry?
Let's first understand what geogrids are and how they work. So geogrids serve the function of capturing and holding the aggregates together, and they are primarily used for reinforcement and stabilization function. As you can see in this image, the apertures in geogrids help in interlocking the aggregates or the soil that is placed over them. The two primary mechanisms of reinforcement are increased bearing capacity and lateral restraint, both of which significantly contribute to increased carrying capacity. The stresses caused by the wheel loading coming over the pavement results in lateral movement of the aggregates, and this in turn affects the stability of the whole pavement arrangement. The geogrid acts as a restraint against this lateral movement, and reduction in lateral movement of the aggregates result in reduction of stresses in the subgrade. What do you think, Branimir? Would you like to add something here?
I think you have explained it quite well. I would add, though, that there is a rule in geosynthetic business, and usually 1 kilogram of crushed stone mixed with 1 kilogram of wall quality soil in the end will result in 2 kilograms of wall quality soil. So, of course, in my opinion, separation is the first important problem which we need to solve when we experience weak or soft soils. Woven geotextiles, for example, they can serve both functions, separation and reinforcement, described as membrane type support load. In this case, the wheel load stresses must be great enough to cause plastic deformation and roots in the subgrade. And if the woven geotextile has a sufficiently high tensile modulus, tensile stresses will develop in the reinforcement, and the vertical component of this membrane stress will help to support the applied wheel loads, as you can see in the image. As tensile stresses within the woven geotextile cannot develop without some elongation, wheel path routing is required to develop the membrane type support. Therefore, this application is generally limited for temporary roads or the first aggregate lift in permanent roadway and railway construction.
Wow, I don't think I've ever understood geogrids or woven geotextiles better, so thank you both. So quite clearly, infrastructure construction can be very challenging, even for the most experienced engineer. So the question is, how does ViaCon solve these challenges?
So you're asking us to reveal our trade secrets.
Yes, I do.
But let me explain how we at ViaCon meet these challenges. As you may have understood, we combine the use of best applicable materials with the most relevant solutions for each specific challenge, after carefully considering all the applicable parameters. For example, geosynthetic reinforcement materials help us not only tackle these kind of challenges, but also to achieve our goals in a sustainable way. Geogrids and woven geotextiles could save hundreds of tons of crushed stone by reducing the required thickness of road and railway structures, and at the same time stabilize and reinforce it in a sustainable way. They can also prevent linear slope failures in case of long or steep slopes covered with material with low parameters. And the irony of the matter is that there is never enough time and money to do it properly, but there is always enough time and money to do it over. And using geosynthetic reinforcement materials help you not to do it over.
So, from what I've understood so far, the use of geosynthetics can contribute not just to the longevity of the construction, but also prove to be a much more cost-efficient alternative. So, putting things in a bit of a more context, let's say that we have a weak soil. How can we decide what type of geogrids we should use?
Well, the easiest thing to do, Frida, would be to contact ViaCon, of course. But on a serious note, there are plenty of products available on the market depending on the technology and the polymers. And we often say that there are no good or bad solutions, but there is definitely a good or bad choice of application for them. So in my opinion, it's very important of being careful in choosing the proper kind of geosynthetic reinforcement material, because depending on the project demands, certain solutions may surpass others, being more suitable for that particular project. Each technology and polymer has its own advantages. HDP extruded geogrids, for example, are famous with resistance to leakage, acid, alkali, and help us to achieve safe performance even the most aggressive conditions. Then we have PVA knitted geogrids, which are best performers when it comes to aggressive environment and the necessity at the same time of low elongations, since low elongation usually is what leads to low deformation in the structures. On the other hand, laid geogrids have very low elongation at nominal strength, and they are very suitable for base course stabilization and reinforcement. Woven geotextiles could be produced with extremely high tensile strengths up to 2,500 kilonewtons per linear meter. And in my opinion, they're an excellent choice for reinforcement and combining separation function as an added value. What do you think, Piri? Have I captured most of the available solutions on the market?
I think you covered most of the available solutions. But I could maybe add that choosing the proper geosynthetic material is key for achieving a reliable solution without compromising one of the most important goals for our generation, to live in harmony with the nature. And I mean, this is something which is what we do at ViaCon, where we not only design solutions for our customers, but we do it in a way to help them achieve their long-term sustainability goals. Protecting our planet has never been more imperative, and therefore ViaCon is following ambitious ESG targets. One of these targets is to monitor the environmental impact by measuring CO2 emissions our solutions emit compared to traditional methods. And being engineers, we are very data-driven, and therefore even our sustainability journey is fueled by facts and figures based on life cycle assessment calculations of our solutions. And I suppose this is what makes our customers trust us.
I totally agree with what you said there, Perry, about sustainability being a journey. And I couldn't agree more on how important facts and figures are to you engineers, having now witnessed it firsthand. So let's talk a bit more about sustainable solutions. We know that the construction industry accounts for a significant part of carbon footprint generated each year. Do we have any figures on the carbon footprint in the construction of roads and railways?
You're right. There are many different studies showing that infrastructure construction accounts for between 12 and 20% of the total construction processes around the world. Therefore, it is our responsibility to use sustainable solutions and to act and to invest now in the future of the upcoming generations. In fact, sustainability, high sustainability of our solutions has never been an optional add-on within ViaCon. And in fact, sustainability is the starting point along with evaluating which solution will be most efficient for our customers and the society at the same time. And within our domain, we have seen that geosynthetic materials are no exception to that approach. There are so many options that we have with Geogrids and woven geotextiles that help us save a lot of energy, fuel, freshwater usage, greenhouse gases, and at the same time to achieve our sustainability and financial goals. Here in this visual, we can see one of the good examples where we can save thousands of tons of compacting, producing, transporting crushed stone with simply installing a single layer of geogrid and non-woven geotextile. And as a result, we have faster and cheaper construction processes combined with reduced carbon footprint, in some cases up to 60-70%.
Wow, this is quite impressive. It is quite reassuring and almost eye-opening for me that we can achieve such sustainable results using geotextiles in infrastructure construction. Are there any other applications to where geogrids could provide a sustainable solution?
Oh, of course, there are definitely plenty of applications. It is important to recognize from the very beginning of the project the necessary lifespan and expected durability of the materials we use. Geogrids must provide at least the same durability as the structure they are incorporated with. The design life for roads and railways is very often up to 100 years, and in some cases even up to 120 years. Hence, using high quality and tested products is crucial for all the stakeholders involved.
I totally agree with you, Piri. And also another very common application of the geogrids and woven geotextiles is the mining industry, where they are very often used for retaining walls, reinforced slopes, stabilization of working platforms and roads. We practically expect that the structures there should be eternal, as usually Any loss of bearing capacity, even after operation, would lead to extreme pollution or harmful environmental impact, and in some cases, even much worse consequences. Providing a solution which will withstand the test of time is very important and depends on many factors like proper design and installation, appropriate type of reinforcement, and polymer selection, especially if we expect aggressive environment, which is very typical in mining industry. Responsibility in mining is huge, and it is crucial that designers pay special attention to the specific details in each project to provide custom and individual approach. And I believe a long-term partnership makes it a lot more viable.
Again, I could not agree more. Taking a slightly different direction now. I know there are some interesting or special projects you guys have been recently involved in. Piri, let's start with hearing from you on such a project.
Well, yeah, we've had some very interesting projects to work with recently. We see that wind and solar farms are a rapidly growing industry, and very often each project requires a special approach. This application is another great example where you can benefit from the advantages of geosynthetic reinforcement materials. The main applications in these projects include paved and access roads, soil reinforcement, and working platforms, usually used to provide crane stability during lifting the heavy elements that windmills consist of. Solutions with Geogrids provide not only initial savings and efficiency during construction, but they also significantly reduce maintenance costs. These type of projects are a great example that Geogrids support not only sustainable construction processes, but also sustainable energy production.
Really impressive. Branimir, tell us about the project that you have been recently involved in where ViaCon provided the complete solution.
As you probably know, Frida, we have had recently some super interesting projects. And one notable project among these is the mining project and the slope which was about to be remediated. Initially, the customer chose a geogrid made of woven polyester. Fortunately, the client contacted us and we were able to warn them in time that this type of polymer is not suitable for the extreme aggressive soil, just the kind that was available on the job site. Our engineers were able to provide an alternative design with a geogrid made of polymer which was resistant to the harsh job site condition. In addition, we provided the complete solution with drainage geocomposites and biodegradable erosion control materials to prevent surface erosion. 5 months after the installation works, we had green slopes, but I believe the highlight here was that we helped our customer to save a lot of time, money, and to avoid failure.
I remember there's yet another example with solutions including geogrids. Piri, perhaps you can share more about that.
Yes, you're right. ViaCon Hungary worked with their customer to help them achieve optimized solution for replacing a traditional reinforced concrete retaining wall. And ViaCon Hungary tackled this challenge by proposing a mechanically stabilized earth wall, so-called MSE wall. And this solution included gabion and concrete facing, combined with geogrid reinforcement and backfill material from a local mine. This approach met the customer's cost and design as well as sustainability requirements. And ViaCon provided full end-to-end solution from design to technical advice to delivery, helping the customer achieve not only their sustainability and ESG goals, but also longer-lasting, easily and rapidly constructed solutions cost efficiently. And there are also many other projects where our MSC walls are combined with other solutions also produced by ViaCon, such as corrugated steel bridges, underpasses, culverts, and wildlife crossings.
It is great to see that in addition to being smart, sustainable, and cost-efficient construction solution, these bridges also have a high aesthetic quality. So Branimir, tell me what kind of support can we provide for these mixed type projects?
thanks to our wide portfolio of offerings in infrastructure construction, providing full end-to-end support with mixed solution project has been our forte. And with our decades-long experience and eye on the future, ViaCon engineers support customers from the very beginning of the project until its finalization. I suppose from our detailed discussion today, we have already established when embarking on an infrastructure construction project, the decision should be not based only on price, but also on speed of construction and lowest environmental impact of the solution. In most of the cases, woven geotextiles and geogrids have all these three advantages compared to the traditional methods with the use of only of natural materials. Our engineers support our partners with a full range of tools for designing solutions with geosynthetic materials and corrugated steel structures. Moreover, using our carbon footprint estimator, we are able to evaluate the sustainability of our solutions, comparing them with the alternative available methods.
And I believe that is how we empower customers, by providing a complete transparent picture of ViaCon solutions, making it easier for them to make informed decisions based on fact, figures, and not just hearsay. Pyri and Branimir, thank you so much for this discussion, sharing your insights into sustainable construction with end-to-end geosynthetic reinforcement, coupled with consultation and partnership with experts, which helps ensure that projects achieve their goals for sustainability and longevity. And thank you all for watching. I hope you gained a deeper understanding of how complete end-to-end solutions can help you build safely and sustainably. And now let's open up for the Q&A session.
All right, so we have received a few questions during the seminar, but please remember you can always post a question using the Q&A icon in the top bar. But let's start with, let's see, Pyri. I think this one is for you. What are the most important technical parameters to consider when choosing geogrids?
I would say the most important parameters, they vary slightly whether the geogrid is used for increase bearing capacity, for example in road structures, or then for stability in slopes. And the most important parameters in geogrids, they are related to tensile strength, but when we aim to increase bearing capacity, tensile strength at low 1 to 3% elongation is typically in important role. So because we want to keep the structure together and all the deformations as little as possible. And when the geogrid is used to increase stability, the most important parameter typically is the long-term design strength and the product-specific long-term reduction factors that are used to calculate the design strength. And as mentioned earlier today, other important parameters are the material of the product, which needs to be right for the intended use and for the environment to guarantee the design durability, and the right aperture size of the geogrid to achieve the optimal interlocking. I guess those are the parameters.
Okay. Let's see. I think Branimir, this one is for you. Are woven geotextile and geogrids resistant to UV rays, and for how long should they be exposed to sunlight?
In general reinforcement, geosynthetic materials are protected and stabilized against UV impact, but the time for which the material could be exposed to sunlight depends heavily on the production technology to protect the material. And I will confirm what Pyri said just a few minutes ago, that using tested materials gives us the best confidence how to protect the geogrids and woven geotextiles. And usually this information is written in the technical data sheets, or it could be provided upon request.
Of course, there are some other parameters which could be evaluated by the designers, like exposure, because in some regions, sun radiation is not as strong as in the others. But I would recommend that if we don't have information when the material should be covered, to do that within 1 day after installation, usually.
Okay. I think maybe, Branimir, this one is also for you. Could woven geotextiles be used for retaining walls? We've seen example, but
Absolutely. Woven geotextiles could be successfully used in retaining walls or reinforced slopes, depending on the inclination of the wall. There are several considerations which need to be taken into account, of course. And the first one is that the connection with the facing elements, if there are such elements, and usually Geogrids provide very good pull-out strength with the facing systems and the facing elements. But very often this is not the case with woven geotextiles due to lack of interlocking effect and less friction with the soil particles. So in that case, wraparound systems very often could be more efficient. And if we don't use a facing system, but we do the wraparound, special measures should be taken to protect the woven geotextiles from the UV radiations, which refers to the previous question. And we need also to protect the woven geotextiles from mechanical damage if the application for the structure is permanent. If the application is temporary, we can use sacrificial geotextile or other material which will provide protection for the wovens which are exposed to sunlight. Colleagues of mine has presented several case studies and cases with retaining walls constructed with high-strength woven geotextiles in Poland during the International Geosynthetic Society conference last year in Rome. And more information could be found at our educational portal viaconacademy.com.
yeah, I think most of the things that we actually talk about today, we can find in either in case studies or documentation on the ViaCon Knowledge Hub later on. So good reinforcement there for everyone to go in there and find more information. But Pyri, I think this one is for you. Where or in what situations are reinforcement geocomposites a preferable choice compared to geogrids?
Yeah. Geocomposites are a combination of geogrid and non-woven in one product. And geocomposite is it's preferred when georeinforcement is installed between the subsoil and the structural layer. So right below at the bottom layer of the structural layer. And typically then the separation and filtration function of non-woven is needed. So you can combine this with one product.
All right.
And yeah, using the geocomposite, it simplifies and saves time in the installation. And this way, of course, increases efficiency on the job site. And it also makes installation a lot easier if the subsoil is extremely soft. So when it's really low bearing capacity of the subsoil.
Okay. Pyri, another one for you. How many layers of geogrids are required in case of very high loads? It's high and low questions.
Yeah. Yeah, geogrids it's typical that they are used in multiple layers, and the typical way to use them is in 1 to 2 layers. But if there are really high loads and typically soft soils, subsoils, geogrids can also be used in multiple layers, and there is no limit for number of layers, and it needs to be designed, but it depends on the load it's coming, the subsoil, the fill material that is used, and the geogrid type, and this needs to be considered. And I think a good example that came to my mind is related to wind farms, where there's really heavy cranes and heavyweight lifting on quite soft soils, and there are structures that are designed that there's been 4 to 6 layers of geogrids every half a meter, so they can withstand extremely heavy loads.
All right.
I can also add.
Yeah.
Oh, yeah, please continue.
No, I was going to hand it over to you, actually.
I can also add that there is not a certain rule for minimum or maximum layers of geogrids. It's everything depends on the soil conditions, as Piri explained, and the external loads. And we have just a requirement in IPGeo that the maximum distance between the geogrids should be 50 centimeters. And then we need to reinforce again. But many studies have shown that the influence of the geogrid to the soil is up to 10-15 centimeters above the geogrid, and then this influence significantly is reduced. And but we have many cases also when we have retaining walls with 60 centimeters of spacing between the geogrids, and they are successfully implemented.
I just want to say thank you for all of you that post questions. I'm trying to keep up with all the ones coming in. Branimir, are geogrids applicable for veneer slope protection?
Veneer slope failure is very common in landfills and in mining construction, and it is usually related to slides of first several centimeters up to 1 or 2 meters of the surface soil down to the slope. This could be caused by different reasons, like too long or too steep slopes compared to the material which we have, compared to the parameters of the material which we have used, and because of excessive water content and external loads which were not predicted initially during the design stage. A geogrid which is anchored in the top of the hill can release from stresses any geosynthetic layers which is below the geogrid, and this could be geomembranes, GCL, or other type of hydroinsulation layers. At the same time, the geogrid will hold any soil and remediation layer if the geogrid is designed and calculated appropriately. We see that this application is mainly in the environmental engineering.
All right. Let's see, what do we have more? Well, I think this one is for Branimir, maybe for both of you, but can you mention any innovation in the development of biodegradable and recyclable geosynthetic material and their potential applications in environmentally sensitive areas? Can I get both of your opinion?
Okay. Should I start, Piri?
Yeah, you can start.
Okay. We discussed today that ViaCon follows ambitious ESG targets, and most of the solutions which we provide are complemented with environmental product declarations. And actually, all the materials which ViaCon produces have environmental product declarations. We also closely follow the new developments in the geosynthetic business, including all possibilities to reduce the environmental impact of our solutions even further. And one option is to use biodegradable materials for erosion control whenever that's possible. Another option is to use materials which are produced from recycled materials, like recycled plastic bottles made of polyester. These innovative geogrids, they can have the same durability, tensile strength, the same performance and applications, and they're practically completely equivalent to standard geogrids, but at the same time, they're able to provide even larger CO2 savings compared to traditional methods. There is also a solution with fully biodegradable materials, but probably Puri can discuss this.
Yeah, I also agree that it's the innovations are mostly related to biodegradable materials and recycled products, and we have biodegradable products such as non-woven product, which is made of which is biodegradable, and then this is something that we see that this will be the future, and we see that this market is developing all the time.
All right. There's another one that just came in now. Wait. Does ViaCon offer geocell, and for what kind of soil reinforcement are geocells applicable? Branimir?
Let's explain what geocells are. They are honeycomb-like geosynthetic material made of polymer, and usually the height is between 5 and 30 centimeters, and the opening is different depending on the application. And yes, we can offer that kind of solution, but very often this is not our first choice, as we recommend it for base core stabilization only when we have limited opportunity to go deep due to geological obstacles, communication, or gas pipelines. Geocells have also very wide applicability in erosion control of steep slopes, water channels, and many other applications. And very often these geocells are combined with non-woven geotextiles below them because we need a separator.
All right. I think that was the last one I had. There was a few similar ones. I hope I've taken everyone. And if there is any more questions, just keep on posting them and we will put them on our ViaCon Academy. So with that said, thank you all for joining us today. And I hope the discussion has helped give you some valuable insights how the right geosynthetic reinforcement materials coupled with appropriate and custom design solution can help construct infrastructure that is long-lasting, resilient, and sustainable. As we mentioned previously, if you'd like to learn more about the challenges we have solved, visit our Knowledge Hub at ViaCon Academy. And please do not hesitate to contact your closest ViaCon representative in Europe, and our engineers will be glad to find a solution for you. A recording of this webinar will be later available on our Knowledge Hub ViaCon Academy, along with the Q&A and also adding on those questions that may come in after this. So, see you soon with more insightful discussion, and until then, keep following us in digital channels and do take care. Thank you.